I'm going to be talking about how I installed the MRCOOL MVP30 centrally ducted heat pump HVAC system. So this is the indoor unit, the air handler unit, and then we have the outdoor unit. So I'll be walking you guys through the stuff that I had to do to get this thing installed and up and running and past inspection. So obviously it's going to vary by your jurisdiction, but in my case, this is what we had to do. And we'll get started. So starting at the very bottom and working our way up here, what I have is a return plenum that I had to build. So I had to use some 2x4s to make like a table. And then from that, this is 26 gauge sheet metal and it's continuous. So basically there is no air leaking in from inside this closet or the crawl space underneath or the attic, because all of the air is coming from this intake right here. And so it goes from there up into this first box right here. This is a Lennox air filter cabinet, which is very nice because it's a standard dimension. It's a 20 by 20 by 5 inch filter. So those 5-inch filters are super thick. The MVP30 does have its own 1-inch filter, but it's a baby compared to this. And so if you have the vertical access to do it, it's very good practice to put in these thicker filters because they have a longer life, and also because there's more surface area for air to move through. It's just easier on your blower motor to circulate air. So ideally you put in the fattest filter you can. Don't go with the stock one if you have that option. And so I'm using zip screws to hold my ductwork together here, as well as the tape and mastic, so that all these seams are sealed. And moving up here, again, you can see the mastic that I put on to seal the transition from air filter cabinet to the air handler unit. And then you can't see it, but there is mastic between the base of my plenum, my return plenum, and the base of the filter cabinet right here. So mastic is honestly the easier stuff to work with. I think it's faster than tape. It might be a little bit messy, but honestly it washes off with water if you're quick. So I highly recommend using mastic all the way if you have that option. But yeah, so that's what we have. This comes out, and then you can just throw in a new standard 20 by 20 by 5 filter when the time comes. It also gets you better air quality. So that's that section. Moving up into here, you'll see that we've got a 3/4 PVC lines. So the reason why you need that is on these units, there is a coil, and that A coil gets very cold when you're in the cooling mode. And as stuff gets cold, it creates condensation, and you have to do something with that condensate, that water that forms. So you have to get it to go outside of your house. So you have a primary and a secondary drain port. This is the primary drain port. Again, 3/4 male threads here for both of these. And then from here, I 90 out because I wanted to give myself clearance to have the secondary drain port also have this thing, which is called an SS1 float switch. And we'll get to the switches in a second, but the point is your condensate is going to flow out here. There is a 1 in 50 slope, or at least a 1/4 inch per foot slope, so that water is going to travel here. Then it goes into a T. This is a U-trap. The reason why you do U-traps and not P-traps is because with these standing water that you can get algae growing in this thing. And so to clean it out, these switches come out like this, and then you can just push a cleaning brush through it. And then this cap also pops off, but you can push whatever's clogging it and get pretty easy access to clean it. So that's why people use these U-traps. And then in my case, my condensate line continues out there, and then it tees, and then it goes into my crawl space, again maintaining at least the 1 in 50 slope, and then it goes out and then terminates basically at least a foot away from the foundation, so that we don't create foundation issues, and we're maintaining all this. And all these joints are glued, so it's got the purple primer and the PVC glue on it, again, so you don't have leaks. But as we're moving up here, you can see that each one of these, so I have 2 float switches. I have one in my P-trap, and basically what this float switch does is if the water level rises, it causes these two wires to have a disconnect in them. And then the same thing also happens with this float switch. And so if for whatever reason water's rising in this thing because I have a clog, the float switch is going to get tripped. One or both of them gets tripped. And as they get tripped, they go up here into my control board up here, which I can show you guys pictures of that. Basically in that control board is where you're cutting power to the R wire. So as soon as the R wire gets cut, it cuts off the system. So if this thing was pooling water and draining water into your foundation or your framing, you want to stop that as soon as possible. And then yeah, so this is a code requirement. You need at least one, but two is even better, just in case one fails or whatever. So that's what we have there. Another thing is you have to support your 3/4 PVC pipe. So even though it looks all rigid, it's not. You know, if you hold a stick out, you'll see it start to sag like that. So I had to add some 2x4 here just to support my my U-trap so that we maintained that proper slope in this system. And so very important that you have that slope again, because if you don't have the right slope, the water isn't going to drain, or it'll just backflow and you'll defeat the whole purpose of all that drainage pipe that you have. And bad story. So again, moving up here, you can also see that I've got a 1/2-inch EMT line coming up here. The reason why I had to do this is because your air handler unit, in my case is a 2.5 ton unit, needs its own dedicated 15 amp 2-pole power supply. So inside of this 4-inch metal box, I literally have a 2-pole switch. So that's 2 hots, which get flipped, and then they energize the 2 hot wires that go through my 1/2-inch flexible conduit here up into the top, and it terminates again powering the air handler unit. Most of that power is just for the blower motor, because that's the thing that uses the most power in this thing. But there are optional electric heat kits that you can put into these things, and so I don't have that, but if I ever did want to, I would have to basically push a new dedicated 30 amp 2-pole circuit to power that as well. I'm not, but that's where we're at. And then per code, you do need a shutoff switch for the that 2-pole 15 amp, like in this closet within eyesight. If I had my main panel or sub panel like nearby, I wouldn't need this, but in my case I have to go outside to turn off the power to this thing, so it's code required to have it here where I can easily see it, turn it off if anyone has to do maintenance on this thing down the road. So that's why we have that one. And then if you look at these wires that are coming up here, so we already know that these black wires are for our 2 float switches, but we also have this one right here. This guy is an 18-2 shielded wire. The 18-2 shielded wires are required to establish RS-485 digital communication between your indoor unit and your outdoor unit. So in my case, this white wire is shielded. It's not the standard 18-2 wire you buy at Home Depot. It needs to be shielded because it's a low voltage wire, so you can get interference in it. And this thing and the outdoor unit are communicating a lot of information with each other in real time. So if you have interference in this wire, it'll cause issues. So I had to buy the special wire and wait for that to get delivered, but you do need this if you want to do things up to the manufacturer specifications. I also am using these little straps just to secure my wires in here so we don't have stuff floating around, especially when I'm trying to, you know, open up the filter and get a new one in there. You don't want that stuff in your way. But again, moving up here, getting this thing in was pretty challenging because this closet, as you can see, is pretty tiny. And in my case, I also have girders in my foundation, so I couldn't have my hole go through my crawl space in one area, so I had to push the hole back here, which dictated where my air handler unit was. So you had to think a bunch of steps ahead, depending on your situation. I'm very jealous of people who have basements where they've got tons of space to walk around this thing. I don't get that luxury. So in my case, I have to just deal with it. And so I do have a hole in the bottom right here, which you guys can see. So basically in that hole, I've got my 2 line sets, or my 3/4 and 3/8 line set for my high side and low side. going into my crawl space. They then bend and then go out that way because my condenser is out there. And then also we've got that 18.2 shielded wire going into that crawl space and then out to that condenser as well for communications. And then something else about, when I was getting this thing up here, because I had to get it off the ground up here and then down. Number one, that's a two-man job at least. But number two is you can make your life a lot easier if you take off these screws, take these panels off. You can take out the blower motor, which is very heavy, and you can also take out the A coil, which is relatively heavy as well. And so if I was to do this again, I would strongly recommend doing that because you're going to make your life a lot easier to get this thing up and into wherever it is if you're doing an upflow configuration in a closet like I am. So it's really challenging to get everything to fit in this tiny little space, and every opportunity you can to make your life easier, you should take it. So yeah, highly recommend doing those types of things. Don't know if I mentioned it as well, but on our condensate line here, you can see back there how it goes to a T, and then that T has a riser pipe, and that riser pipe is open because you want to have air to replace whatever water's coming down your pipe. So that's a T, and then the tip of that T by the manufacturer specifications has to be at least 2 inches taller than the top of that drain port right there. But in that T, then the water just drops straight down into my crawl space. Then I again do like a 90, and then my drain pipe goes out that way. So a lot of stuff had to happen. Obviously I had to do this before I put in this air handler unit, because once it was in there, I have no chance of doing that. So again, moving up here, this is 18.7 thermostat wire, and I just bought a blank wall plate, and I bought a grommet for about 60 cents at my local hardware store and just shoved that in here so it's protected and shielded. And I also ran the thermostat wire in my drywall here while I had access to it, but it's all protected up there to the best of my ability. And so that's what we had on that side. And then obviously we've got our unit in here, and on top of the unit, I've got the 1/2-inch power line coming in here, and then I had a transition ductwork to go from the existing opening that they have into the opening that my house from the 50s has right here. So a lot of complex duct transition sheet metal work had to be done. This is not something you can buy off the shelf. You just have to learn how to bend the 26 gauge sheet metal, and you just do it. And then in my case, I wrapped it with insulation, and you also want to make sure this is some of the HVAC tape, which helps protect it. But on top of that, you do want to make sure that you're wrapping it because inspectors will fail you if they don't see insulation where they want to see it. So do make sure of that, and then you can even see a little bit of the fiberglass popping through. So once this thing goes up into my attic, it's insulated as well as it can be. And then in my case also, when I had access to this closet, because this is in a hallway, I just taped and mudded every single drywall joint that I could see and had access to, because even though this isn't necessarily like a finished space per se, for fire resistance, I didn't want to fail and have to literally take this all out just because of me not doing that. So, I mean, if you want to go above and beyond, you can also paint it, but in my case, just adding in drywall to patch all the holes that were there and the mud as well as I could, just so that I have the best chance of passing. The inspection was kind of the priority there. So that is the indoor air handler unit, and it's controlled by a Nest thermostat right here, and that's why I had to use the 18.7 wire. So that brown wire goes up here and then over the ceiling and then terminates right here in this guy, and then there is a dip switch on the control board for the unit. And so if you are going to not use the proprietary MRCOOL thermostat they include, you do have to make sure that you set SW1 number 1 to the on position. It's off by default, but that's the other thing for this particular install. So yep, that's all there is to that part. Something else I'm going to say real quick is that on this insulation that they provide, this is the Novak line set from MRCOOL. It basically goes on, there are torque specs, so I just marked it once I had it to spec. But on these things, you do, like, I've just heard bad things about how this handles up in the UV light over time. So if this is going to be exposed outside, you want to get some additional tape from the, it's called UV resistant tape for these line sets. And so you just wrap it around as best you can, and keeping your as much of the metal as possible, insulated as possible, is beneficial because it'll help prevent condensation when this thing is in the cold mode. So when this thing is chilling your house, if you don't insulate everything properly, it'll start dripping water. And then in addition to, potentially causing framing damage, the water can trickle into this and then cause corrosion on the copper pipes. These copper pipes that are in these line sets is a lot thinner than the copper that's used in the water supply lines, and so it can get pinhole leaks pretty easily, and if you get those, then you're gonna have to run a new line set. So yeah, and then another thing is for passing inspections, if you can see all the way in there, you can see there's some orange stuff that you can just barely make out, but every single penetration that you make into the crawl space or from the outside has to be sealed with that fire foam stuff. So even the penetration I made for dropping my condensate line down, ideally, you minimize the number of penetrations you have. That's why I have a big one for the line set, plus signal wire, plus this conduit's all coming out of just one hole, just so I had one hole to fill. But yeah, there's a second one there that I had to fill as well. So that is the indoor air handler unit section, and we'll move on to the condenser now. Okay, this is the outdoor unit, the condenser. This thing weighed 200 pounds, so it was very hard to pick up. So again, two-man job at least. But this is the concrete pad that I built for it. Note that it's raised off the ground a good amount, because if we ever do get flooding, you don't want this thing to be submerged. And then these are rubber vibration dampers just to help extend the life of this guy. And then in terms of how I did the penetration into the crawl space, I took a piece of 4-inch PVC just so I could have a liner to protect my line set and the flexible EMT that I have. And I used a roof vent, and then I just stuccoed around it to make this as watertight as possible. And it's got a rubber boot that can be replaced over time because obviously these things fail. But this is the best solution I could think of for not getting leaks into my framing while still getting these big holes made for all this stuff. And if you can see deep in there, I don't know if it comes out, but point is, again, any penetration has to be sealed with that fire foam stuff. And then this, the reason why we have this one is for that 18.2 signal wire, the shielded one. And then this guy right here is 30 amp 2-pole. So it goes out to this non-fused disconnect. And so this guy, you just pull that to turn it off. I used number 8 wires to my main panel, but really you only need number 10s. So that if down the road I ever wanted to do a larger condenser or whatever, like I have that option. But the wires go into this guy. I use number 10s from here to here, copper. And so we go into here to power our condenser. This is that 30 amp 2-pole. So 2 hots plus 1 ground. And then you've got the S1, S2, which is that 18.2 wire. And that guy plugs into your condenser. So, and then same theme as earlier for your line sets. You want to make sure that you're insulating them as much as possible, because every piece of exposed line set that you have is another opportunity for heat to go in or out of your system. So you want to contain that so that you're just heating or cooling your house, not the rest of the world. And then this is Sure Tape UV resistant stuff. And so to protect the foam on the line set insulations, you just wrap it all around this thing. I also spray painted the 4-inch PVC pipe just so that had some additional protection, because if you have unpainted PVC, it'll crack and deteriorate more quickly. And then, you know, side note, but I just threw in a new foundation vent because this house had old ones. So these louvered ones help make sure that the water doesn't go into the crawl space. It stays on the outside and then just drips off the house. But yeah, so that is the outdoor unit, and hope it helps.